Thank you very much. Yeah, that looks like me, so we're on the right slide. Yes, my name is Dunkley. I've been working with software like 15 years now, mostly in the front-end space, but over the last 4 or 5 years, I've got more and more interested into the modeling of systems, which is what brought me to domain-driven design. And I'm not quite able to say that I'm an expert, but with the help of meetups like this, wider reading, lots and lots of trial and error, I've learned that DDD has lots of great benefits. One of which is that it can help prevent emu wars. Now, for some reason, this wasn't actually in the original book, nor any of the spin-offs, which I think is a tragic shame. So this is my attempt to fix that little omission for us. So how we're going to do that? We're going to do it in 4 parts. So a little bit, as mentioned, a sort of history lesson that serves as a little silly code analogy. Then we'll make that a little bit more real world, so the same sort of problems, but a more realistic domain. After that, we'll see how DDD can come in and help us with some of the problems that we faced in part 1 and 2. And then just a little quick summary at the end. Right, so you might be able to tell from my accent, I'm not originally from Australia. I came over here about 5 years ago from the UK. And before that, I only knew like the classic dangerous Australian animals. The snakes, obviously, the spiders. I've been warned a lot about the drop bears. Yet to see one, but plenty of warnings. But I must admit that I didn't actually know that Australia had emus. I was oblivious to this. And I also didn't know that they were dangerous. And I'd never heard of a country going to war with an animal before. So if, like me, back then you could do with just a little recap, a tiny little history lesson, this is for you. So it was just after World War I, and new farmers in Western Australia were losing most of their crops to the emus here. And to fix this, the army was brought in with their cutting-edge Lewis light machine guns, which my artist tells me they definitely looked like that. So anyway, the army comes along, and they were given the goal that they had to kill all the pesky emus. So with a bunch of soldiers and a bunch of machine guns, Australia went to war with the emu. Any history experts in here know who won this particular war? Anyone? The emus, yes. It was definitely the emu. There was just too many of them. They were also too fast. They were too agile. Apologies, that's the wrong slide there. They were too agile. They were nimble. They could run and jump and hide over things. So Australia had to make do with being the runners-up in this particular war. But it's fair to say that the Australians didn't lose just because of the strengths of the emus, but they also sort of lost because of the physical constraints imposed upon them. They played an important role. For example, just not having enough soldiers and, well, not enough machine guns. And in software, we don't typically suffer from at least those kinds of constraints. Our weapon of choice is code. And basically, we can always write more code. In fact, in the world now of AI and Copilot, we've got so little constraint. I'm going to say, well, exaggerate a tiny bit and say we've got near infinite code at our fingertips. And no other industry really has this. This is kind of our superpower as an industry. But what if we could go back in time and bestow this lack of constraints, our superpower, to those Western Australians? So now they have got near infinite soldiers, near infinite machine guns. Who's going to win this time? I mean, it makes sense. It's the humans. Finally, the humans win. Because with those constraints gone, it doesn't matter how fast or how agile the emu are, they're going to lose. In this timeline, the farmers have got to keep their crops. And more importantly, the bin chicken will get to take its rightful place on the Australian coat of arms, which I feel should have been like that from the start. So, by translating over this superpower, our superpower of this lack of constraints, we've completely rewritten history. So, let's play with this just a little bit more, and instead of giving those guys our superpower, let's give ourselves, the coders of today, their problem. So, you come into work tomorrow, and the boss says, our biggest client has a problem with too many emus. So we get presented with the task. kill all the pesky emus. So you say, well, that sounds pretty weird, boss, but sure, I'll get coding. And I'm guessing most people here are familiar with OO, so we're going to say that a soldier is equivalent to a class, and maybe a method is a machine gun is a public method on one of those classes. And we're going to start coding. We'll write a class, add a method, manually test it with a bunch of emus in, and well, yeah, we've picked off one or two, but we've barely made a dent. But that's fine. That's no problem. We weren't really expecting it to work straight away anyway. And you remember, we've got that superpower. We can always write more code. So obviously, that's what we're going to do. That original class is now delegating down to another couple with their own methods, and we'll manually test again. And well, yeah, it's better. It's not a lot better, though. We've only picked off a few more. But you've got to remember, this is a big, complex problem. Although I'm sure at least some of you out there are thinking, this is not a complex problem. I could make this really trivial. Anyone got an idea? How could you make this trivial in code?
Something with regex.
Regex? Regex? Eh? I wasn't ready for that answer. See, what I expected people to say was... Pardon? Add more servers, even better. I thought you would all go for add a loop. You've come up with even more innovative solutions than I was expecting. But anyhow, that is the closest thing to actual code you will see in this presentation. I do believe that is passable. I'm sure people can read that. But anyway, even with that loop or your guys' solution, they would be great ideas, but they would completely ruin my silly hypothetical. So instead, what we're going to say is that this group of emus is not equivalent to an array of emus or anything we can solve with your solutions. Instead, we're going to say that each emu represents a distinct and complex and unique problem in of itself. So maybe one's hiding behind a rock, one's really far away, and this guy seems to think he's some sort of medieval knight of some sort. Not sure how that happens, but it's possible. Well, it doesn't really matter on the individual nature of the problem, but my point is that that loop is not going to save us anymore. But again, that doesn't really matter. We're back to the code. We can add more code, more classes, do some more manual testing. And yeah, that's, more than half gone now? We're making progress. Although, yes, the boss keeps looking at their calendar and looking back at us unhappy, seeing the days and sprints pass by. So they're not particularly happy, but, that's their fault for not understanding how developer estimates really work, isn't it? And anyway, we can't worry about that. There's code to be written. So, we're back here, and I'm sure you can all see where it's going. Yes, more comes out. And we'll manually test it again, and oh, no, that's gone backwards, hasn't it? So some of the emus have come back to life, and some have been upgraded to be T-Rexes. Again, not entirely sure how that's happened, but that's okay. Just means there's some bugs that we need to look into and investigate. And now the boss is really staring daggers at us at this point, and we're feeling quite uncomfortable. But we're going to pull through, maybe do a late shift, maybe work a bit on the weekend, and we're going to fix that, manually test it again, and hooray, we've solved it this time. We've got rid of all the pesky emus. Now, obviously, neither the boss nor the clients, they don't actually see all this code we've been spending all this time on. To them, it's just a black box, so we don't feel completely appreciated. They don't know where our blood, sweat, and tears have gone. But, that's fine. Who cares? It finally works. Well, except we need to get it through code review, don't we? And our pseudo class diagram, very, very pseudo class diagram here, is just giving a very zoomed out view. But you've got to remember that a few weeks and a few sprints have passed at this point. So this PR is big, 2,000 lines or so, which I hope everyone thinks is big. If you don't, you have my condolences. So when we do find somebody that will take up the task and have a look for us, it's so big and complex that really they're only going to find a few typos, aren't they? Maybe they'll find a few emos. Possibly they'll find us an Elmo. But, it's all very complex, boring, and they're bound to have their own code that they would much, much rather be writing. So obviously at some point they're just going to give up, by which I mean they're going to say, looks good to me. But before they do that, they realize that we haven't got any tests. Right, okay, well, we're well-meaning professional developers. We can't have that. So somewhat begrudgingly, we start adding tests, one for each class, where every other class is mocked out, and we're kind of just proving that the methods output whatever they currently output, because, yeah, that'll have to do, won't it? But who cares? Who cares? We've done it. We've solved this one. So unlike in the real world, us software developers with our superpower, we've won our digital emu war. Much better. Although the thing is, you could ask, at what cost have we won? So you remember our goal was kill all the pesky emus, and in reality we would be really testing out at this outermost scope to really prove that we've achieved that goal consistently. And we're just testing at these lower scopes where everything else is mocked out, and have we proven that we can kill all the pesky emus? Well, again, sort of, but yeah, not really, no. And the code base is extremely complicated. Our reviewer, they basically gave up trying to look at it. We just got a few, typos that were somewhat useful, but didn't make a big dent. And, we understand it roughly, but, give that a few months. Clearly been a rough few months for us. And the boss and the client are going to reckon this whole project took far too long. We're dreading the day that they find more bugs, and God help us if they come asking for new features. Maybe if a couple of the emus have learned to ride a skateboard, or one of them's invented the flamethrower. Refactoring this code base to combat those new problems is not going to be easy, and not something we're going to look forward to. So I think it's fair to say that we've crushed the problem under an avalanche of code. And what does it cost us? Well, I'm going to argue it's cost us maintainability and extensibility. Now, at this point, you might be thinking, wasn't this meant to be a DDD talk? Because all we've ascertained so far is that emu wars are, in the real world, unwinnable, and in code, they're winnable, but not maintainable and not extendable, which would be a fair criticism. So what we're going to do now is move closer to the real world by swapping out that silly domain with a more realistic one. So, not just any domain, obviously we're going for the ubiquitous, pun intended, DDD domain, at least presentation domain of e-commerce. So, let's imagine that it's an already established e-commerce store. And there's APIs for the shopper here to view products, add them to a basket, to pay and to check out, and for the store manager, view customers, view incoming orders, and set them as dispatched. And all of this works fine. Every day money goes from here to here, and goods go from there to there, and everyone's basically happy. And backing up just to fill the story, let's imagine we've got a whole bunch of microservices, because microservices are still cool, aren't they? Well, either way, we come into work tomorrow, and the boss says the store manager needs to update orders. Now, that sounds a hell of a lot more reasonable than that silly emu problem. So you go, no problem, boss, I'll get coding. And again, we'll write a class, a method, and that method's probably wired up to our web framework of choice, taking in some sort of update order command from the API, and somewhere in the body of that class, we're reaching out to the database, getting the order, messing with it, putting it back again. And again, we're going to keep things simple for the point of this presentation, and we'll take things like authentication, permissions, security, and logging all for granted. Not that we would ever do that in the real world. Now, we've basically already got our update order endpoint coded up. It's already there. So we manually test it, and yeah, old order in, updated order out. Looks great. And not only that, it's small enough that we're going to add tests, and the PR will be fairly small this time round. And we'll get that quickly approved, and we'll deploy it, and the boss will be happy with us. Well, at least for a little while, because they're going to come back to us unhappy at some point because, yes, they've found a bug, haven't they? So there's always going to be at least one bug. So what's the bug? some shoppers receive too many items. It's interesting. So we go back and look at our code, and we can't really see anything obvious that would do that. So it's all right, we'll go to the logs then. And here at the logs, we find a pattern. So bug occurs when the order is updated to have fewer products, but that's happening after the order was already set as ready for dispatch, meaning that the customer is receiving like the original amount of goods and not the reduced amount of goods that they should have got from the update. Which, yeah, not great, but it's fine, back to the code. It's just an edge case. We can fix that. And we'll add a few more classes to handle this little issue. So, maybe over here, this guy's reaching out to some shipping service to check if the order was already marked as dispatch. And, if it has, then maybe we've got a new 400 you can't update after the order is already ready for dispatch error over here. And I know that sounds a bit much for their own classes, but all I'm illustrating here is there's greater responsibility, so your code base is growing. It's got to go somewhere. Anyhow, now we'll do some manual testing. We'll add some new unit tests. Again, a little code review. And we'll tell the boss it's fixed. They'll be happy. We'll deploy it. And, oh, no, time's passed. It's a problem with having a live system, isn't it? Yeah, there's another bug. Okay, what's this one? Some shoppers are being undercharged. Now, the store manager is particularly unhappy with this one for some unknown reason. So we better look at that one pretty quick. And luckily, we still remember the last bug, and we're seasoned developers. It's bound to be another race condition, isn't it? So straight to the logs this time. And we're right, there happens to be an event where products are being added to an order, but that is happening after payment was already captured. Well, that's not so good, meaning that the shopper was charged the original lesser price and not the enlarged price that would have taken into account those new added items. Right, okay, that's not great, but it's all right. Back to the code we go, and, exercising our superpower, and we're adding even more classes, and, over here, maybe we're reaching out to some payment service, checking if the payment was already taken, and again, we'll have some new 400 can't update after payment captured. And over here, we've got our old friends, which we're handling the dispatch issue. And because we've got a few little scenarios here, we've probably got some clever patterns helping to orchestrate and work out which scenarios we want to send our code paths down, helping to tie it all together. So we do some more manual testing, which takes a little bit longer, because we've got more scenarios to keep in mind now, and then we're going to add a few more unit tests, which, take a bit more longer because things are getting complex, and that middle section there is fairly abstract now. And that's also true for the code review. It's going to take a little time more, but eventually it goes through. We tell the boss it's fixed. We deploy it, and they're happy, and these things come in threes, don't they? Obviously, there was going to be a third bug. You know the drill. So what's this one? Some shoppers receive empty boxes. Okay, that sounds a bit special. So we look at the logs, and this time we don't see anything obvious, actually, and go to the code, and that looks all reasonable, other than my little font's gone out of line there. So we don't see anything obvious there. Right, okay, and we're kind of a little stuck until one day the boss, we overhear them saying that it only seems to happen with cancelled orders. And that sets off a little light bulb, because if we think back to our APIs, we haven't given the store manager a cancel order endpoint. So we find out the store manager has actually been using our new update order endpoint to gradually remove every single item from an order. But unfortunately, the order still technically exists in our system, and our very heavily automated, efficient warehouse honors that order and ships it on out anyway. And again, I would forgive you at this point if you think that's silly. That's a rather contrived example for an already silly talk. But I can tell you that for a company I may or may not have worked for many years ago in the UK, this may or may not have definitely happened. Okay, we don't feel good about this, but it's fine. I mean, you know what we're doing, back to the code, adding more code, and maybe this guy is going to keep an eye if the last item was taken, and if it was, we're going to invalidate the delivery info with the shipping service. And that's not perfect because now the warehouse ends up with boxes with like invalid labels on them, but at least they're not going out the door anymore. At least it's slightly better. And, we've seen all the complexity here, so maybe we've reached for the old design patterns book to see if there's any that we haven't ticked off yet. Because what we want to do is take this code and make it way, way better. Yeah, that's definitely better. And again, we're going to do some manual testing, add unit tests, go through the code reviews, which now seems to be taking an absolute eternity because of all those mounting scenarios, all of that complexity that we've got to keep in mind now. But eventually we tell the boss it's fixed, and they're happy because we deploy it, and then, oh, don't worry, I wouldn't put you through that again. It's fine, it's fine. We're all good now. So yes, there is still the occasional race condition where an update is happening roughly at the same time that payment's captured. And yeah, there's still that thing in the warehouse where there's these boxes that they don't know what to do with. But they're rare enough that we can live with it. The company's mostly happy. It's all right. And now maybe going through this, you've probably noticed that our pseudo class diagram here looks very familiar. And it is not just lazy illustration. That is definitely part of it, but it's not just that. What it actually was a heavy-handed attempt at clever foreshadowing. No? That work? Maybe. Because what I'm going to argue here is that just like our code-based emu war, we have, again, solved our update order problem with an absolute avalanche of code again. And again, if we were to ask ourselves questions like, at what cost have we solved this problem, we're going to get pretty similar answers because, our problem was the store manager needs to update orders, and to prove that, we've done that consistently and that works, we'd have to test it, this outermost scope again, which in this scenario would be even trickier with all that I/O of databases and the in-process calls to other microservices that maybe we should not be doing. So yeah, we've probably got a few happy path little tests, but mostly we're relying on the same sort of tests at these lower scopes that mock out everything else. So again, have we proved that update order works? Well, again, sort of, but yeah, not really. And again, this code base is pretty complicated. We did get it through code review because we split it into those 4 sections. So our reviewer managed. But a new starter isn't going to get that view of it. They're going to have to take it all in all at once, aren't they? And ourselves in the future, are we that confident that we're going to remember all this complexity and be able to find our way through this? Not sure on that. The boss and the client, again, think that the project was too slow. And if anything, it was one largely driven by bugs and not features. And again, it's a code base that nobody's really looking forward to refactoring or working with in the future. So just like before, we've crushed the problem with an avalanche of code, and it's cost us maintainability and extensibility again. Now, often when we're in these situations as designers or developers, we tell ourselves things like, complex problems require complex solutions. Or we console ourselves by saying, you can't remove complexity, you can only move it around, as a way of sort of justifying the mad scientist code base that we've just built. And for the vast majority of my career, I've been saying and thinking exactly those things. But luckily, this is where a little bit of domain-driven design and a few practices help to qualify some of those assumptions, and in doing so, might help us make a few improvements to our code base and our lives as developers. So, where to start but with event storming, obviously. So if we were to plot the events within our e-commerce system prior to that update order coming across, we would see very normal stuff like the products being listed, viewed, added to cart, delivery address added, payment details added, payment authorized, order submitted, stock reserved, payment taken, and eventually order confirmed, confirmation email sent, stock picked, and finally order shipped. It's a bit of a mouthful. But that's not necessarily to say that our system is event-driven in like a technical sense, but nonetheless, these events happen even if they're just implicit in your code. So let's now replay our problem statement. So the store manager needs to update orders. So if you just slap the past tense on that, obviously you've got order updated, yeah? It sounds reasonable. And where's it going on our timeline? Well, obviously it can't go before the order was submitted because that's when it first came into existence, so it's got to be sometime after that, hasn't it? So maybe just after the order was taken, or well, maybe after we took stock but the payment was taken, or actually no, it could happen after that, or even after it was confirmed and, oh no, after stock was picked. And yeah, in truth, yeah, it could happen multiple times all across our timeline here, which is kind of a horrible thing that points out that they can happen the exact same time as some other extremely key events in our system. And if we think back to those bugs we were fixing earlier, for example, when the shoppers received too many items, the fact that the order could be updated at any time was largely the underlying cause. So clearly there is a bit of a modeling smell here. And if you haven't seen a modeling smell before, I'm pretty sure that's what they look like. And I would argue that this smell intensifies. Oh, my slides are a little funny. Are we zoomed in at all? No? Oh, it's gone a bit strange. Anyway, what we've got there is we're going to have a gradient of domain-specific over to hopelessly generic. So if we start plotting out some of our verbs, we've got added to cart, stop picked. They sound all right. They sound very e-commerce-y. They look pretty good, but then we're going to add a few more, reserved, listed. Well, there's a few domains they could pop up in, but it's not too bad. Added, viewed, yeah, they're getting pretty generic. But over here, if my heading was in the right place, would tell you is hopelessly generic, is order updated. So, why is order updated so bad? What's so bad about updated? Well, in truth, it's hard to think of any digital representation of anything that couldn't, in theory, at least be updated. So, phones get updated, games get updated, even relationship statuses, well, yeah, now and then they also get updated. So I think it's fair to say that this event doesn't really convey or telegraph any intent whatsoever. It doesn't really signify anything. But hey, that was our brief. Yeah, that's how the work came to us. The store manager needs to update orders. And this is where I have to come clean a little bit, where I sort of left a few details out earlier when I was back talking about the emu wars at the start of all this, because I kind of presented the problem as, the goal was to kill all the pesky emus, which was kind of true, but it wasn't the whole story. Now, if you remember, that goal existed because the emus kept eating all of the new farmers' crops. And, well, why did they do that? Well, unfortunately, these new farms were set up against long-standing emu migration routes. What a great place to put a new farm, eh? So why did we pick those? Why the substandard choice of location for these farms? Well, in fact, it was a way for the Australian government to give returning World War I soldiers cheap land on which to become farmers and to become self-sufficient. So, in reality, the goal was never actually kill all the pesky emus. What that was merely an implementation detail of a possible solution to the real problem of how to find these World War I veterans, these soldiers, employment. Now, I can't tell you that I'm actually an expert in the early 1900s Australian job market, I'm afraid. But I think it's fair to say that there may have been other possible solutions to this problem. And again, I'm sure none of these alternatives would have been perfect, but I'm also extremely confident that none of them would have resulted in the need to start an unwinnable war against an army of 6-foot-tall birds. So, with all that in mind, I'd argue that we're kind of doing the same thing with our update orders scenario over here. That all of that code complexity, which was mirrored in the event storming, the poor testability and the bugs that resulted, plus our evolutioning language, were all heuristics, or again, modeling smells that were trying to tell us, trying to indicate that, yeah, update orders was again an implementation detail masquerading as a problem statement. This, in fact, was just another silly little emu war. So, if we think back to our bugs, the store manager, they never actually wanted like an arbitrary update to an order, like a random change in there. That's not what they were after. What the store manager was wanting when they were removing products was a way to ensure shoppers only receive and pay for the items they really want. And when they were adding items during order updates, it was to allow shoppers to easily receive extra items that they had forgotten. And finally, when the store manager was removing all of the products from an order, that was just to allow shoppers an easy way to back out of an order altogether. And you'll notice that nowhere in these problem statements do we use that horrible word update. So, to paraphrase a keynote, the key takeaway here is not to put implementation details. Don't let them sneak into your problem statements. Because at worst, it becomes a self-fulfilling prophecy, as we saw here. And at best, it just massively reduces your creativity in problem solving. So let's get rid of this horrible API and start afresh. So if we take each of these problem statements one at a time, maybe we'll start with allow shoppers to receive extra items that they forgot. Without the words update order in there, there's probably an absolute ton of ways that this problem could be addressed. The shopper themselves would probably be perfectly happy if the store manager magically appeared at their front door with the missing items in one hand and just a card reader in the other. That would be fantastic. Unfortunately, though, the store manager is not magic and would probably prefer that we solve this problem with code. So, if we think through just a possible way of solving this, one might be a place supplementary order endpoint. Horribly uncatchy, but I'm sure you all already know what this is going to do. It would take in a reference to the original order and a list of items and quantities that were forgotten, and it would give out a sort of new unpaid order, maybe referencing or taking some details from the previous one. And before we even start writing any code, what we can do is sense check this against our little timeline here. So, the nice thing is, regardless of where we put supplementary order placed, again, not very catchy, but it tells you what it's doing, regardless of where we put it, all it's actually going to do is start a new swim lane for us, which can carry on in isolation just like it was any other order. And the fantastic thing that we've done here is we've avoided events that come along and contradict or undermine previous events that have happened in the system. So, we can already tell that that is going to mean fewer calls out to these other microservices, far fewer branches and logic to handle all that, so it can be more ignorant and decoupled from the wider system, which should make it easier to review and easier to test. And this is just one potential solution, just one potential solution. There's probably even better ones out there. But for now, given I'm running through time, let's just put a little tick next to that and we'll have a look at the other two. So how about these guys? Surely there's no way of solving these, again, without ending up with those fighting events and rewrites of history. Well, has anyone seen this before on Uber Eats? So I've placed my order for some delicious sushi, and it's going to auto-confirm in about 10 seconds, but I can actually back out of this if I want to. Or, email clients. So I'm writing an email, I press send, and then I'm given the opportunity to undo the sending of that email. What's happening here? Are we going out to other people's inboxes and deleting things? Well, obviously we can't be doing that. So how these things work is that these events, the system is telling me that these events have happened. But it's only after a sort of safe period of time that the rest of the world, other systems and services get to find out about this. So maybe we can use this same sort of technique back in our e-commerce hypothetical. So luckily, in e-commerce, buyer's remorse kicks in really, really fast. It's normally the instant after you've pressed pay that you realize, oh, I didn't actually need 2 of the exact same t-shirt, Or maybe, you bought a couple of tickets to see the new Joker movie seconds before reading the reviews. The horror of that poor decision is going to kick in quick. And we can kind of take advantage of that, the speed of buyer's remorse. And thinking back to our bugs, things went wrong when we took payments or shipped orders effectively based on out-of-date information. And if we trace each of them back, or the events and processes that kick them off, eventually we'll get to order submitted, which seems like a good candidate for the one that we want to keep quiet, at least for a little while. And we can imagine doing that, much like Uber Eats and that email client does, by making room for a sort of order received and back out period expired sort of split in our logic. So a typical order would just flow across all of these absolutely as normal. But should a shopper, wish to back out entirely, or maybe turn that order back into just a basket that they can modify, there's now a safe window in which they can do it. Right, and if you compare that back to update order, what we had before in our old solution, update order, when that came along, our order updated event, it had a large blast radius where it really undermined and contradicted a lot of events, leading to a lot of complexity and bugs. But now with this new proposed solution, we've got a much smaller blast radius that cancel order will affect. It doesn't really seem to undermine anything because the events that would have followed it simply now never happen. And again, this might not be perfect. This is just us developers spitballing ideas. There's probably better solutions out there. Really, we'd need to get in the room with our experts and hash it all out and make sure whatever we come up with is the right fit for the business. But again, given I've got only a few minutes left, what we're going to say is they're good enough, and we're going to run with them. So, our complex and buggy update order API is now gone. It's been replaced. First of all, with this little place supplementary order endpoint, which alone allows us to meet that goal of allow shoppers to easily receive extra items that they forgot. Plus, we made a change to our submit order logic to add this order received, order submitted little split, which came along with a little cancel order endpoint and this tiny little back out period expired cronjon. So those three things come together to help meet those two other way more specific goals. They're allowing shoppers to easily back out of an order, and also they're ensuring that shoppers only receive and pay for the items they really want, because you could cancel that order, turn it back into a basket, make whatever amendments you need to do. And even without diving into the code, I think it's fair to say that these are far more single purpose and will thus be less complex than what we had before. And if we revisit our old truisms, complex problems require complex solutions, we can see that we're now benefiting from the other side of this same coin. So simple problems only need simple solutions. And the way we were able to get that was with DDD helping us to tackle this guy. You cannot remove complexity, you can only move it around. Because with our DDD hats on, which I believe there's still a few left in the gift shop, we can see that this statement is kind of true, but it needs an asterisk and a few amendments. So you cannot remove necessary complexity from your current level of abstraction, but go up a level of abstraction because maybe you can remove some from there. Now, I do appreciate that this is awfully unmemorable. So how about instead of that, we go back to a visual. So what we've got here is levels of abstraction up the side and time left to right at the bottom. So you can imagine that that first model of our e-commerce system, we'll call it V1, our mental model, was there. And when that problem statement came along of the store manager needs to update orders, that basically directly spawned a V2 because update order, it had to update the order. It was basically a given. And because of that, it was directly encoded in code with all the complexity that we saw before. But we didn't like that. We didn't like all the bugs. We didn't see it as something that would live too long and we wouldn't be that proud of. So with a bit of thinking, following some of those heuristics and DDD practices, we rethought it. And what we did was we turned that very vague and awful problem statement of update order into three far more specific and business-centric goals. And when we came back to the code level to actually implement the solutions to that, we were able to do it with far less complexity than what we had before. So you can remove complexity, and this has got to be one of my favorite possibilities that was opened up to me by domain-driven design. So often when our solution space is better aligned with the problem space, you don't have to solve as many problems because quite a few of it is accidental complexity that simply evaporates. So how on earth do I wrap all this up? Well, unless your domain is either e-commerce or the early 1900s Australian job market. Anyone in that one? No? Well, unfortunately, even if it was, the technical and modeling solutions I've portrayed here probably wouldn't be of much direct value. But what I do hope that you might take away from this is a way to stop your superpower from becoming a bit of a curse. And that the next time yourself or a colleague, you find yourselves, 6 or 7 classes deep in a problem with far too much complexity and maybe more than its fair share of bugs, rather than crushing that problem under yet another avalanche of code, you remember this rather silly talk. Maybe check out domain-driven design, do a bit of event storming, check your ubiquitous language, and make sure you're not solving the wrong problem in the very first place. And definitely make sure that you're not accidentally fighting your own unmaintainable and inextensible emu war. Thank you very much. So I've got a tiny bit more for you because my talk was super up in the clouds, high level. If you want something that gets you from event storming all the way down to actual code, I strongly recommend this talk by Michael Plod, Getting Module Boundaries Right with DDD. It is fantastic. And if nothing else, I hope you enjoyed the illustrations that were throughout this talk. They were done by my better half, Pilar Bassa, and you can find more of her work there. And lastly, if you want to see this talk again or some more of my ramblings, you can find it up there. So thank you very much again. Thank you.